Welcome to Crackit. Today we are going to discuss on what service discovery is, how is it achieved in our microservices, what is service registration, how can we register our microservices, and how is load balancing achieved in microservices if multiple instances of the microservices is running in an application. That is what we are going to see today. Try to understand what service registry is, what service discovery is, and what is client side load balancing in this slide. So for the service registry, usually we will have a central server or servers in our microservices architecture. So that central servers will hold the address information, IP addresses of all the microservices that is running in my network. How will this central server know the IP addresses of all these microservices? Because in our previous video, we discussed that the IP addresses of this microservices are dynamic. So how will we know, or how will this central server, or there is a chance that there may be multiple central servers as well. So how will these central servers know the IP addresses of the microservices architecture even if the IP addresses are generated dynamically? So let's try to understand. Suppose I am starting my microservices M1 as 3 instances in my microservices architecture. So what will happen now? These 3 microservices will start, and these 3 microservices will have 3 different IP addresses, and after the start of these 3 microservices, these 3 instances of the microservice M1, these 3 instances will send their IP address to the client servers. So if there is only one client server, the central server, the IP address will be sent to only one. If there is multiple servers, each of these instances will send to any of the servers, and those servers will communicate with each other and get the information from one of the other servers through the gossiping protocol. So what is gossiping protocol? Suppose say I have central server C1 and C2. M1 sends information to C1. The first instance of M1 sends information to C1, and the second and third instances of M1 send information to C2. So what will happen? These C1 and C2 follows gossiping protocol. So what is gossiping protocol? Now C1 will send information about the first instance of microservice M1 to C2, and the C2 will send the information of the 2 instances of M1 to C1, and always C1 and C2 will be updated with all the information. Suppose say similarly I have microservices M2 running in 2 instances and M3 running in 3 instances. What will happen? These 3 microservice instances will send their IP information to the servers, and the server will now have all the information about the microservices running in this microservices network. Why? Because each of the microservices, during its startup, it will send its IP information to the central server. This is called as service registration. So what is service registration? If any of the microservices is starting in my microservices network, that will get registered itself to the central server by providing its IP information. This is called as service registration. Suppose I have auto-scaling implemented in my microservices architecture and the traffic to M1 got reduced. So what will happen? One of the instances of M2 should be destroyed, or this application should be stopped. Why? Because I have auto-scaling in place, and the traffic to my microservice M1 is reduced. So I just need 2 instances and I don't want one more instance. That's what the auto scaling is detected. So it is going to destroy the instance M1. Let's see. So it identifies and it has destroyed. So now ideally what will happen? So this instance of M1 will deregister itself from the central server when it gets stopped. So what is it? Whenever any instance of the microservice application is stopped, or it becomes unhealthy, or it gets terminated to any of these reasons, it should deregister itself from the central server. What does that mean? It will remove its IP address information of the destroyed instance from the central server. That is called as service deregistration. If for any reason any of the instances is down, that specific IP information will get removed from the central server, deregistered from the central server. Also, there is something called heartbeats. So let's see what it is. So to this central server, always my microservices which in all are alive, for every 5 seconds or for every 10 seconds that we need to set, and for that every few seconds all the running microservice instances need to send its heartbeat to the central server. If for any reason any of the microservice instances is not sending its heartbeat, then the central server will remove that IP information from its server information. So what is it? To make sure that the central server has the valid IP information, each of the microservices needs to send its heartbeat to the central servers for every few seconds to confirm its availability or to confirm its running status to the central server. If for any reason any of the microservices is down, it will not send the heartbeat, so that if the central server doesn't receive heartbeat for for the specified time, the central server will remove the IP of that specific instance from its addresses. Now, what is service discovery? So what is service discovery? Let's now consider my microservice M1 is dependent on my microservice M2. So M1 needs to communicate to M2 to fetch the response of M2, and by processing M2's response, M1 will send its response to the client. So this is the flow. So client will call M1, M1 internally needs to call M2, M2 will send its response to M1, and M1 will process M2's response along with few other information, formats its response and send back to the client. So this is how the flow is. So how will M1 identify M2 now? So is it the responsibility of M1 or the responsibility of M2? In the service discovery, we have two types of service discovery. One is client-side service discovery and the other one is server-side service discovery. So we will be using client-side service discovery in this example. So first, the server-side service discovery will happen in the cloud environments. Suppose I am going to deploy all my microservices to the Kubernetes network. There in the Kubernetes network, the server-side service discovery will happen. So we will try to understand what client-side service discovery is now. So what is client-side service discovery? As I told earlier, M1 need to communicate to M2 to fetch its response. So what will M1 do? Is it the responsibility of M2 to provide information to M1, or is it the responsibility of M1 to know the details about M2? So it is the responsibility of M1. If we are using client-side service discovery, it is always the responsibility of M1, that is the calling microservice, to know about the M2 microservice. So what will M1 do? M1 microservice will now go to central server and ask for the details of M2 microservice. Now the central server will check in its IP addresses about the M2 microservice. So my central server has two instances of M2 running. So what will the central server do? This central server will respond to M1 with two IP addresses of M1. So it is the responsibility of M1 to discover about the M2. This is called as service discovery. M1 service discovering about M2. Client side load balancing now. As I told earlier, Now the central server responds to M1 with two IP addresses of M2. Now M1 needs to decide which specific instance of M2 it needs to call. So M1 needs to perform load balancing on which specific instance it needs to call. So how will it do? How will it do this client side load balancing? So M1 should follow some algorithm, like it will either follow round robin algorithm, or it will identify which instance is called for a very least time, or it will use some other custom algorithm. So M1 will use any one of these algorithms or any of the custom algorithm, and it needs to decide on which specific instance of M2 it needs to call. So that load balancing also the specific microservice M1 will do. This is called as client side load balancing. So this is also the responsibility of M1, and that is called as client side load balancing. So with now we are clear what service registration is, what service discovery is, what is client side service discovery, what is load balancing, and what is client side load balancing. So even though this concept is really difficult to explain, but with coding this is very easy with Spring Cloud. In our next video we'll see on how we can implement all these in our coding. We'll meet soon in coding a session of service discovery, service registration, and load balancing. Thanks for watching Crack It. Please do like, share, comment, and subscribe for the updates. Please let us know in the comment section if you want to discuss any specific topic. We'll discuss it for sure.